Okay, so today we're gonna be looking at polynomials. So for the first problem, we have functions x to the power of 3, f of x and g of x. Find f of x plus g of x and f of x minus g of x. And find a constant where f of x plus c times g of x, where it will create a polynomial of 2. Okay, so just do A, B, and C, and then I'll explain later. Let's give you guys 5 minutes. Okay, so um, I think you guys probably have enough time. So let's see solutions for A and B, f of x plus g of x and f of x minus g of x. So here you can see the solutions, and I'll give you a minute to check your work, and yeah. And if you have any questions, please ask. Okay, and on to the part C. So what C is asking is for us to find a constant where when we add these two functions together, it will have a degree of 2. And what degree of 2 means, it just means max exponent in the polynomial is x squared. So we had to cancel out the x to the power of 3s. So x to the power of 3 times negative 3, x to the power of 3 plus negative 3x to the power of 3, that would give us negative 2x to the power of 3. So what we need to do is make this smaller to negative x cubed. So c would have to be 1/3. So 1/3 times 3, that would give negative x to the power of 3, and that will cancel out on the other x cubed, and you would be left with a degree of 2, as shown here. See, negative x to the power of 3 plus x to the power of 3, they cancel out, and that leaves this with it leaves 2 as a maximum degree. Okay. Another method is that you can do this. This is like elimination. We learn to solve for solutions, kind of, and system of equations. This is kind of like that. Here's a question to all of you. Just type it into chat what you guys think. Is the sum of two polynomials always a polynomial? You guys like 2 minutes to think about that? Just type it in the chat. We have one yes from Cheese. Any other people? You can direct message me if you want. I got a yes from Kristen. Okay, we have one person saying no. Okay, so let's go to the next slide, and it should explain things. So a polynomial definition is a sum of terms that each have a constant times a variable to some non-negative power. So if you're adding two polynomials, you can cancel out the terms, but the constant will always be there. The constant is 14 to the power of 0, and that is still a polynomial because a degree 0. This is just the definition makes it so that this is the case. Okay. Next here. So, think about this: f of x and g of x added together is h of x. Is it possible for the degree of h of x to be higher than these two functions added together? or the degree to be smaller. So yeah. And just type what you think in the chat. And once we get 3 responses, we'll move on to the solution. Okay, you have 1 no. A no for, is that a yes for A and a no for B from cheese? Is that what you're saying? Okay, so it is not possible. A is false because when you add 2 polynomials together, it can't get bigger because you have to multiply in order to get the degrees to go higher. So x cubed plus x cubed, no matter how big the coefficient of x cubed is, it will always stay as x cubed when you add it with another x cubed function. However, if you add x cubed with a negative x cubed and they cancel out, it will become a smaller degree. So in this case, it would go from degree of 3 to degree of 1. So yeah, that's the case with polynomials and degrees. All right, now we're gonna look at multiplying polynomials together and see if the degree changes. So do this function, just use the FOIL method, so it's 3y squared times y cubed, 2y, y, and 7. Just do it for all of them and add them together. This is your first time, so it might take a little while. I'll give you guys 4 minutes and I'll be back at 5:19. And if you're stuck or anything, just message me in the chat and I'll help you out. Okay, so we got two answers from Kristen and Cheese. Kristen got everything right except for the last term. So here's the how you would distribute it. The first way was the way I told you guys, like FOIL, the distributed property. Um, yeah, so just multiply everything, and then the next, you would just multiply the functions and move them over a slot. So there's 7 times plus times 3. It's like um, normal. It's like kind of like a long division with polynomials as well. Okay, next. Next, here's the same question. Must the product of two polynomials always be a polynomial? So if two polynomials are multiplied together, are they still only polynomial? Let's think about that for a minute and then I'll explain the answer. Okay, we got a no from Alvin and a yes from Cheese. Yes from Kristen as well. Okay, so the answer is yes, and here it is. So yeah. So polynomial just means that the term can be a constant or whatever, but the exponent just can't be a radical or negative. And when you multiply two polynomials together, it won't become negative or a radical. It was like 1 times 2, 3 times 4. That it's not going to become a negative or a radical. Because it'd be polynomials to begin with. So yeah. Okay, so here's some questions, and I'm gonna have you work through and think about this for let's say 7 minutes, and then we'll meet back. You can ask questions through the chat or like unmute yourself. Okay, so I got two responses, one from Alvin and one from Kristen. So we're gonna walk through them. So Kristen said, how's degree h related to degrees of f of x and g of x? She said that it's the degree h equals degree of f plus the degree of g. And that is true for most cases. But the thing is that, yeah, it holds true except for the degree of polynomial 0, where it's undefined. So yeah, so that's good. Yeah, so it works. And then for B, the answer is yes. That's because if two coefficients, as it said in the beginning, if f of x and g of x leading terms have coefficient of 1, 1 times 1 is their maximum degree has, I mean, the coefficient of the maximum degree of h of x has to be 1, because it's either f of x or g of x, this is maximum degree, which is 1, or it's them multiplied together, which is 1 times 1, which is also 1. So B, the product is also monic. So B is yes. C, explains that 2 of x can multiply, 2x squared and 1/2 x squared can multiply together, and you would get a term that is monic. So f of x and g of x do not have to be monic, so that's a no. So this D, if the constant term f of x is 0, must the constant term of h of x be 0? So yeah, the constant term has to be 0, because, wait, let me read this again. I think I read it wrong, so it's confusing. Yeah, so if 0 multiplied by 0 would also be 0. And for E, it'll be impossible for constant terms of f of x and g of x to both be non-zero if the constant term of h of x is also 0. So E is a no. So yeah. So the important takeaways from this is the degree of f of x times g of x is degrees, the highest degree from f and g added together, and the product of f of x and g of x is going to be the leading term. Yeah. Okay. So you guys solve this problem, and we'll be back in 5 minutes. Okay, so I'm gonna pull up the next slide, which will help you if you're still stuck. Yeah. So just if you're stuck and can't figure out what to do, just or you're doing or trying to expand the entire function, you can look at this to help you out. Okay, so I'm not gonna explain how to do it for people who don't know in a timely manner. So basically, we're solving for I think we're solving for A, right? Yeah. So we're trying to find what terms in expansion product consist of a constant times x. So is it asking you which terms um are are part of x? I mean, a part of okay, no, never mind. Wait, what is this? The f of x equals x. Okay, so it's asking which terms have a constant times x. So the only ones are going to be the only ones that are going to be important to us to find a, which is in part b. It'll be 9 and 7x and 5 and ax. Because those are the because a is a linear term, and those are the only ones that are going to be affected. So here we can see the only terms we get when multiplying each term in the first polynomial by each term in the second are 7x and 5 and 9 and a of x. So here you would get 7x plus 5 and plus 9 ax equals 37x. And then you can solve this equation, which will give a. Yeah. So that's how you would solve this problem. If you have any questions, please ask. I might have not explained it in the best way, so yeah, please ask because we're going to be doing challenge problems after this. B equals 5. Yeah, that's correct. Okay, so B, we would do the same thing. You would find the terms that multiply together to get the expanded term of, what was it? 13x to the fourth. And then you would solve for B, which is the constant next to that. And you get B equals 5. So the important takeaway is that you can use appropriate products of term f of x and a term of g of x to simplify problems to find the constants of the polynomials. So yeah. Okay, so work through these challenge problems, and I'll give you guys 10 minutes on this. I mean 8 minutes on these, 2 minutes for each question. And ask me if you have any questions. Okay. So let's go through these challenge problems. So for the first solution, you're just expanding the equation. So this is what you should get at the end. I'll take a second to check that. I'll give 15 more seconds. Okay. For the next problem B, it asks when does h of x equals 0. So all the products, it's already in this form, so you can um, just say this x equals p, q, or r. So yeah, and for C, this is how you would write the what's it called, the exponents in terms of uh the equation. So you would just put this in and compare it. So here you can see that x squared, the coefficient would just be 1. X cubed, sorry. X squared, it would just be negative p, negative q, negative r. A1 would just be this. I think there's a typo here, actually. Yeah, there's a typo here. Oh, sorry, this should be x squared. So that's why A2 would be this. It should be x squared right here. Um, and yeah, so you guys get the general gist of it. And yeah, all you have to do is compare them to find the coefficients. Um, what is the challenge problem? Some of these values. What is the product of these values? So yeah, so the C is explained right here. I'll give you 30 seconds and then we'll move on. Okay. For the challenge, we're not gonna worry about that for now. You can look at it later. And we have another challenge problem. This one is short, so I'll give you guys 3 minutes to work on this. Okay, so for what constant k must f of k always equal the sum of the coefficients of f(x) for any polynomial f? So here's the solution. You have to find the value of k such that. So if you have it set equal to 1, k set equal to 1, then it would equal the sum of its coefficients. F, yeah, f of 1 would be f, what the sum of its coefficients. Okay. The next challenge problem, the polynomial functions f and g satisfy f of y equals 3y squared minus y plus 1. G, what are all the possible values for the sum of coefficients of g? Okay, so you guys work through this problem. I'll give you guys 5 more minutes on this one. Okay, so with this problem, uh, from this problem, all you have to do is to set one of the solutions is to set f of g of one to f of g of y to one, so you get the coefficients, and then we have f of k equal to 31, because we know that f of g of y is 31. It is 31, yeah. So we set it to 31. So, and then from here you just solve f3. You get 3k squared minus k plus 1 equals 31. And you subtract 31 from both sides, and factoring it, and then you factor it to get 3k minus 10 and k plus 3. So you get 10 over 3 and negative 3. And there's another solution to this as well, which you can read right now. I'll give you guys a minute to read it, and then we go to the next one. Okay, let's go to the next one. So this is just a homework problem. So we're just gonna do this page, and then I'm gonna end the class earlier today because I have to go a little early today. And also this unit isn't that extensive, so this is just all we have to do. All we're going to cover, I mean. Okay, so this is last problem. I mean, we're gonna go over the solutions for these. So find f of y, f of 1, and g of 3. This is pretty basic. Um, yeah, just plug them in, and you get these. First is 88, and b is y to the yeah. B is this. You just add the two functions together, and you get that. And what's the last one? Yeah, so the last one you just subtract. Yeah, you just start f of y from both sides. Get this. So you can just do g of y minus f of y to get h of y. And you just minus subtract these and make sure you do them all in correct order. And yeah. The last homework problem, I'm gonna have to end class early because I have the meetings after this class that moved earlier. So I won't be able to walk you guys through this, but you guys can look at this in the email Dinesh is gonna send. It contains the PowerPoint and stuff and the homework. So office hours are still Saturdays, 7 to 8 Central Time and 5 to 6 Pacific Time and 8 to 9 a.m. on Sundays, China time. So yeah, good class today. And if you have any questions, please ask now. You guys can leave.